Hello everyone and welcome to Physical Chemistry for Life Sciences. Again, your instructor Ismail Badran is speaking. Today I will go through the details of the project for this course, and you will find all the details in the document that I have uploaded to the Blackboard. And the first thing is you need to go over the details of this document, read line by line, and understand what the objectives and what the details of your project. So basically this project is all geared towards the kinetics of a drug that you will be assigned. This project will be done in groups, and you will be working with your group in order to finalize it by the due line mentioned in the Blackboard. So every details is here. Each group is assigned a data set that you will find in your Blackboard as well. So for example, groups 1 to 3, they were going to work in data set number 1. Groups 4 to 5, they're going to work in data set number 2, and so on. So please stick to your data set and don't open the other data sets. And so this project is composed of 3 parts. The first part is a written report on your assigned drug. So it's going to be between 2-3 pages. And then parts in B and C are just calculations in Excel and graphing in order to determine some kinetic parameters. The marking scheme for this project is that part A will, the whole project is 15 marks. Part A will be 5 marks, part B is 7, part C is 1.5. There's a half mark for the references and citations, and 1 mark for the general look of the report and the formatting and everything. And one of the most important things that you want to pay attention to is the format of your project, that it should actually follow this scheme. You have to have a title page similar to the one that you used for the lab, and then you're gonna have to use Times New Roman as your font, size 11. Heading and subheadings, they're gonna be size 12 bolded, and the spacing, you will have double spacing. So add 3 points before and 6 points after each paragraph, and you're gonna have also to have page numbering. So please stick to this format for this project, just to be consistent for everyone. So if you open your data set, you will find something like this actually. So this is, for example, data set number 1, and you see the drug here, it's azithromycin. So this is your drug that you're gonna work with. You will have also time and concentration data. You have also at the bottom here temperature and rate constant data for the part C of the project. So for the first thing, you're going to work on azithromycin, and you come up with a brief introduction on the drug. So as I mentioned in the details of the project, you will need to use respected resources for that. So general internet or Facebook or whatever resources that, of course, not acceptable in the scientific field. You need to use textbooks, peer-reviewed journals, or some respected websites. Probably the first thing is you're gonna try is Access Pharmacy. So if you go to the QUI library and you go to the website, the website is kind of slow these days. So if you go to e-resources on the main website and you search for the word pharmacy, that will bring you the online resources available for pharmacy, and you will see Access Pharmacy is the first one. So Access Pharmacy is actually a very good tool in order to search for drugs and their information. This is a locked website, but it's open to students from Qatar University. So if you can, the website is not opening now for some reason, but once it's open, you will have something like this. This is the website itself. Okay, you have to open it from the Qatar University website in order to deal the information. But if you go to drugs and then just say azithromycin for your drug, of course every group will have to work on different drug. But here the website will ask you to log in information and so on. So this is one of the resources that you can use to build your report. At least you need 3 resources, of course. To write your report, you're not going to stick for one thing. Probably now, if you want to search for azithromycin on the website, on Google, I mean, you'll have tons of resources on this, but you have to be careful which one to choose. So this one is, the first result here is from WebMed, which I don't believe in it anyway. Probably one good is the FDA, I think. Probably this one. So if you just go azithromycin FDA. FDA is the Food and Drugs Agency in the United States. This is a very good respected resource as well. You can benefit from this information. Okay, you can talk about the structure of the drug, some of the. I pointed out the points that you want to talk about in the report. Okay. And one more resource is Google Scholar itself. So if you go to Google Scholar, and also you search for azithromycin, there are hundreds, of course, on peer-reviewed journals on azithromycin. To limit them down, maybe you can arrange from since 2016. That's like four years. You can choose some of these journals to support any ideas that you feel important for this drug and recent, for example, development in the drug or general uses. So basically you want to tell us a story about this drug, okay? Just 2-3 pages. What do you feel important about it? Never copy and paste, okay? Avoid plagiarism, as I said. You need to read and summarize in your own language what is important for this drug for the general reader, okay? And maybe anything related to kinetics. You are welcome to send me a draft of your report. I will give you general feedback on it. I'm not gonna mark or grade your report before the due line, but I can give you just quick feedback if you are on the right track or not. Okay, so that's for the first part of the project. Now the second part is for the data set. Now if you go to here, it says all details here. So for part P, the timing considerations are provided for assigned drugs. Now use the data to do 5 things. First, plot the consideration time to show the exponential decay behavior of the drug elimination. And you can fit this curve to an exponential decay function just to show us the exponential behavior of the elimination reaction. We need also to determine the order of the elimination of the drug from the human body, and in this case you're gonna need to plot 3 graphs to show if it's 0, first or second order. Once you determine the order, you can determine the rate constant from the slope and the half-life, and how long does it take for drug to be 95% eliminated. So I'm gonna show you how to do this in Excel. The first thing is you can select your data, and then you go insert, and you choose scatter for your type of graph. So this looks like a very nice exponential decay here. You can, of course, use this to add your axis titles and whatever you like. Okay, everything has to be here named correctly. So the y-axis will be azithromycin. Let's say you can name it whatever you like. This is milligram per liter. The x-axis is always time, and this is in hour. Be careful about the units because each group will have different units. Now sometimes, okay, so this looks like a very nice. Now you cannot fit this straight line because it's not a straight line. Rather, this one looks like an exponential decay function. So if you could click right on it and add trend line in Excel, that will give you options to which fitting you like. Clearly this is not linear, so you can use exponential, which is the first one. Now this is fitting to a very beautiful exponential curve. You can add the r-square and fitting equation right here. You can click in the box and make this a little bit bigger, just in order for us to see it. So now you have an r-square value, which is the regression coefficient, to be almost 1. So this is very good exponential decay function. So of course the title has to be changed as well. So this is alizarin decay. Okay, alizarin sorry, not L3, this is erythromycin elimination kinetics, whatever you like, okay? Just any title that makes sense for me. Okay, so that's the first graph. Basically, you will not use this graph to obtain anything, just this is showing the elimination kinetics. But now, in order to determine the rate law, as we said on the lecture, we studied 3 rate laws, which is the 0, first, and second order. If you want to test this, if it's 0 first, and you need to do 3 graphs. One is concentration versus time, another one is ln concentration versus time, and the other one is 1 over concentration over time. And the best one will give you, of course, the rate. So to do this, you need here to do the concentration is given, so that's good to go for 0 order. Now I'm going to make ln concentration, okay, for erythromycin. You can name this whatever you like, okay, AZM, whatever. And I'm going to make also 1 over the concentration of LZS. So in Excel, you can just write, to find the ln, you can click equal and then just start typing ln, and that will give you the function. You click on this value, click enter, and then you scroll this down. For this, you can say equals 1 divided by the concentration. You click enter in the keyboard, you bring the mouse here, and with this black cross, you can just drag down, or you can simply just double click on this, and that will do. The numbers looks ugly, so I like actually to format them all in a good format. So that's going to be number, and you can play with the significant digits for each one the way you like. They don't have to be in the same number of decimal places, all of them. It depends. So for the hour, maybe 1 decimal place is enough. So okay, whatever you feel it's good for you. Now we have these ready: the time, the concentration, and the ln. Okay, so you can click this and this, select the data here, go insert, scatter, and then just keep. So this is for 0 order, and this is okay. So this is the graph for 0 order reaction, and now we need to plot this. We need to fit this into a linear equation. So you can add trend line, and this is linear. So show equation, show r square square. So clearly this is not good. It looks like this is not 0 order, and most drugs, they don't follow 0 order elimination anyway. And enzymes and catalysts, they do. So the r square is 0.8589, almost 0.9, which is a low value. Now, instead of just doing the graph again, what actually I can give you a hint here is that you can make this graph the best look that you can. You can take out these lines. Actually, this is not necessary. You can format it. You can format the curve the way you like. Okay, and you make it look good. Now, what you can do is you can duplicate this curve. Okay, to have it in the same size and the same format. And now, if you click on this, instead of having it in concentration versus time, that's going to be ln. So you just move this one here. Okay, and that is now a very good R square value. So this is called now first order. And then you have the third line. Of course, you have to change the X and Y, and you make a third one for the second order reaction. Once you finish the 3 graphs, you compare the R square values, and then you determine the order of reaction. So it will be one of them. It's either 0, first, or second. Once you determine the order, you can take the fitting equation and you obtain the rate constant from the slope, and you use it to determine the half-life and the other things mentioned in the questions or in the project. Okay, now these graphs sometimes they are do not actually look good because of the x and y intersections here. So I will leave this to you to play with. You can play this with these options here to the right, and you bring this axis down to maybe minus 2.5. It depends on your numbers, of course. And you make this graph looks good without having the x-axis here in the middle, and without having also empty areas. So for instance here, when people doing this, sometimes Excel will do something like that. So you will find there is so empty area in the scale here in the graph. So you need to adjust your x-axis in order to be it look good. The most important information as you go, and this is something I should have done from the beginning, is you should save your files in a name that is different than in the name that is provided to you. So I'm just going to save this in the desktop now, and this is very important. How do you name your files? You just don't name them the provided name from Excel. You can name this, for example, group 1 kinetics azithromycin, okay, or whatever, okay. And then you name it, you're sure that you save it somehow. Because at the end, you will be submitting only 2 files, which are the report, okay, and the Excel file only. For this part, for the part C, which is the obtaining the activation energy from a temperature and rate constant, I will leave you to do that based on the skills I taught you today. That should be not a problem. Okay, so once you are done with the graphing, so basically you will have a total of probably 5 graphs. So this is the elimination kinetics in general. You get 3 graphs for the kinetics part, and you have also 1 graph here for the activation energy. So that's kind of 5 graphs. Now you can take these graphs to after you format them, of course, and they look good. This one probably needs some bolded x and y axis. You can copy this and you bring it to Microsoft Word. This is too big. Okay, you make it the same size, of course. Oh, okay. I will leave you to do that. Okay, just make it nicer. So, of course, each graph would need a caption. So this is called Figure 1. Let's say this is 0 or first order, whatever. First order elimination kinetics of metformin, for example, or whatever your drug is. And you can actually tabulate your results after you finish. You can insert a table in Microsoft Word, okay, and you tabulate your results, like first order, second order, whatever, and you put your slope, intercept, R-square. You can name this table, table 1, and you comment on that table. I advise you to read some maybe papers or textbooks on how you present your data. Again, you are always welcome to consult with me, send me a draft, and I will give you feedback on this.